Hey everyone, welcome back. Today we're getting into 7-3 in our book, that is showing triangles are similar. This is lesson 2 in our similarity unit. So let's get after it. Today, to add to your notes right as we get started, I kind of want to give you a little bit of a roadmap for where we're headed. We're going to learn 3 things today. We're going to learn about AA, we're going to learn about SAS, and we're going to learn about SSS. We're going to learn how they're applied and what the expectations are in my class for what you need to do if you want to demonstrate understanding, okay? You could probably guess right now what the A's and the S's stand for because these are probably pretty familiar to us since we did congruence. AA is angle, angle, and side, angle, side, and then side, side, side. So let's get into what I'm talking about and what I mean. We're going to start with angle, angle. Okay, and here it is. All it says is if we know that 2 angles of a triangle are congruent to the 2 angles of another triangle, then we can guarantee those triangles are similar. So if we can demonstrate that 2 angles match 2 corresponding angles or are congruent to 2 corresponding angles, that's enough. Let's look at a visual and see what that does. So guys, let's talk about the y first. Okay, the y is, and notice, this angle matches that angle, and this angle matches that angle. So yes, we do have an angle-angle situation, but here's why, and we'll do it with numbers first, okay? So let's say that this is an 80-degree angle. And let's say that's a 30-degree angle. Well, that means that this is also a 30-degree angle, and that's an 80-degree angle. Okay, well, what about that third angle? Well, let's see. You have 30 and you have 80, so let's add them together. And we get 110, which means that when we take 180 and we subtract 110, we get 70. Okay, so that's 70. And we would do the same math here, and that's also 70. Okay, so some people wonder, wait a minute, don't we need the third A on that? Because angle, 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 don't we need 3 letters? Well, no, and here's why. Because we just demonstrated that if you know that the 2 angles match, R and T matches L and P, then automatically the third angle will match. Okay, and so now that we've shown that here, we don't have to prove that anymore. That's a really good reason why we don't need that third angle, or we don't need to talk about the third angle. 2 angles is enough. Okay, now let's take a look at how we use it. Okay, here's an example. Okay, are the triangles similar? Why or why not? Okay, right now I see that we have one angle that matches another. So we have angle. What we're wondering is there another angle somewhere that we could have? Okay, and so you may want to pause the video and draw this. You may want to try to figure out where there's another pair of angles. And remember, we're not saying, well, wait, it kind of looks like it. No, it's not like that. What we're looking for is something that we know for a mathematical fact that the 2 angles are equal. And folks, where that is right here in the middle. This angle, WSR, is congruent to this angle, VSB. Now, do you remember why? Okay, the reason for that is those are vertical angles. Okay, and the way I've been explaining that in class is anytime you see a bow tie, that's going to be a vertical. See the bow tie here? Or anytime you see the letter X, automatically there's going to be vertical angles. See, that's kind of a stretched out X right there. So vertical angles. Now, here's what you need for my class. You need to say, are they similar? Yeah. Okay, why? Because of AA. And then you also have to explain that there are vertical angles. Now, the way I've written this on here is totally fine because I'm demonstrating understanding. Saying, hey, one of the angles is a pair of vertical angles. The vertical angles are right here. And also we have a set of labeled angles, so 2 sets of angles are labeled. What you see on your screen would get you full points for me. Here comes our second concept of the day. Now, side angle side. This visually is going to work the exact same way that it did with congruence, but there's one major difference, and I've got it highlighted down below. Okay, so you need to show that one angle in a triangle is congruent to another, and then you need to show that the sides that include that angle are not congruent. That's what it was for congruence. We have to show that they are proportional, and that's why we've been working with proportions so much, so we can demonstrate that. Okay, so let's take a look and do an example. Okay. I suggest right here that you pause the video and draw down this picture for yourself. Okay, and here's the first thing I'm going to notice. It jumps out at me right away that I have a pair of vertical angles right here, so I'm going to label those. Vertical angles. Okay, and so the next thing I want to look at is I'm looking where these side lengths are written. I have an 18 and a 12 right there, and they do include the angle. I have a 24 and a 36 right there, and that includes the angle. So what a lot of brand new students do is they go, oh, side angle side, sweet. That's not quite enough, okay, because we learned a minute ago we have to show that the side lengths are proportional. Okay, it's not a big deal, but we need to show the work. Okay, so what we're going to do is we're going to pick a side length. The one I'm going to pick is 36. And folks, the question then for you would be which side length has to go with 36? Or where is the corresponding side length on the other shape? Okay, and that's right over here at 18. And then I'm going to pick my other side lengths. So one thing I'm going to make a note of right here, I put the bigger number on top, and so in my other fraction, I better put the bigger number on top. The two remaining numbers are 24 and 12. They are in corresponding locations. So I'm going to put a 24 and a 12, and I'm going to grab a calculator real quick. Now, guys, there's two ways you can do this, okay? One of the ways you can do it is you can divide 36 by 18 right now. That's 2. 24 divided by 12 is 2. If you show that, that totally does it because that's a true math statement. The other way you could do it is you could cross multiply, and that's what I'm going to do right now. The only reason I'm choosing to show that in this video is because that's what I have found that my students are a little bit more comfortable with. It's just more familiar to them, and so that's what I'm going to show. So 432 equals, and that was when I did 18 times 24. Now I'm going to type in my calculator 12 times 36, and I also get 432. Cool. So that checks out. That's wonderful. Now here's what you need to understand the expectation is. Folks, if you write SAS, okay, for every time you write the letter S, you need to have a fraction that goes with it. Okay, we have those right here. I'm annotating those. Every time you write an A, unless it was given, which no angles were given, you need to have a reason written down why we know there's a pair of congruent angles. And so I've totally done that here. I've got my work right here. I've got my work right here. People, if all you do on this question is write SAS, you're not going to get many points for it, okay? You need to demonstrate understanding. The way you do that is with this proportion and by explaining that angle. All right, now time for side, side, side. Okay, very similar. I used the word similar. Very similar to what we had so far. So side, 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 it means three sides are going to be labeled, and all you have to show is the three sides are proportional. Now be careful. A lot of people want them to be congruent. But remember, we're not talking about congruence. We're talking about similarity. Okay, so let's look at an example or two. Okay, here's an example. Okay, we want to show that these are similar. Okay, and so all the sides are labeled. That suggests to us that maybe it's going to be side, side, side. And so here's the easiest way to do that. I'm going to start with a number. I pick 6. And 6 corresponds with, we have to think about how did this shape turn into this shape? Yeah, I mean, it was dilated. It got bigger. But it looks to me like it also rotated. And so it looks to me like this 6 would go with that 8. Okay, that's my first fraction. Okay. Now, I need to pick a different number. I'm going to pick this 6. This 6, when it rotates, looks like it goes with that 8. So I'm going to put 6 over 8. And notice, because I picked the smaller number on top here, I also have to be consistent, pick the smaller number on top there. There's my second fraction. Let's go to my third fraction. Now I have a 9. 9 has to go with 12. Smaller number goes first. 9 over 12. And so I've written out my three fractions. And folks, I said smaller number goes first. You could have just as easily picked 8 first. That would have been fine. If you pick 8, then it would say 8 over 6, 8 over 6, and 12 over 9. All these flip. This is not quite enough. I have to show what all these are. So I'm going to show that this equals 0.75. Type it in a calculator. This is the same thing, so of course it's the same, 0.75. And I can type this one in a calculator or simplify the fraction, and I get 0.75 on that as well. And since I showed that all three of these have the same similarity ratio, I'm done. Okay, that's enough work to show that it's side, side, side. So now we've gone through 3 examples of 3 different theorems and shown how they work. Now we're going to have a couple examples where I'm not telling you up front what the answer is going to be, and we're going to try to figure out what it is. So let's do that now. The suggestion here is pause your video, draw the picture, see if you can determine is it angle, angle, side, or side, 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 and try to show the necessary work in order to get full credit. Okay, when you're ready, here we go. Okay, guys, this is going to be side, angle, side. And the way I know that is I see an angle right here, and it's actually touching both of my labeled sides. Okay, and so that's kind of a giveaway to me that that's what I'm going to shoot for. And so the way I'm going to set this up is I'm going to take 8 and 6, 8 and 6. And one trick that I like to do, I like to actually draw an arrow from there to there. And then I'm going to set up the other one, and the only other numbers are 4 and 3. Here's why I like the arrow. When I draw arrows, what I realize is these arrows have to be pointing the same direction. So sometimes, and guys, I ever got really confused on this when I took geometry. Sometimes I would get the numbers in the wrong places over here. But now I see, oh, 4 points toward 3, 8 points toward 6, 8 before 6, 4 before 3. So it goes 4 and 3, just like that. We're going to cross multiply. 4 times 6 is 24. 8 times 3 is also 24. And so I have work here. I have work here. I don't have to write anything for A because that was given right there. And so this is done for full points. Okay, now check this against what you wrote. Okay, you made a prediction before you watched this. So Did you pick side angle side? Did you write down fractions? Did you cross multiply them? If you did, then you totally get this right now, and that's fantastic. If not, let's do a couple more examples, get a little bit better at it. Okay, here's our next one. Again, pause the video, draw the picture, try this for yourself. And here we go. They tell us MX is perpendicular. What does perpendicular mean? Well, that means it makes 90-degree angle. Okay, so I'm going to label that in, 90-degree angle, 90-degree angle. So in each triangle, we have one label angled right here. We have another one there, and these ones match. So this is angle, angle. And that's done. That's all it is. Okay, let's do this one. Let's try to find out about similar sides, or excuse me, about proportional sides. We're going to find a side length, and then looks like we're going to wrap up for today. Okay, so here goes. What's the length of TR? I'm going to first of all put a variable over here. That matches what we've been learning. Okay, so what is the length of TR given that these are similar triangles? Okay, again, guys, pause the video, give it a shot, unpause when you are ready. Okay, here I go. I'm going to put X, and X is in the same spot as 5. I'd like you to practice that trick where we put in the arrow, X, 5, and the reason that's going to be helpful is that's going to tell you what order these go in here, because if you put a 3 and then a 24, you see how the arrows are going opposite directions? That's wrong. Okay, they have to go the same direction. They have to correspond in the same way. So 24 goes to 3. 24 to 3. Let's do a little bit of cross multiplying. When I do that, I get 3x equals, and I'm going to type that in my calculator really quick, 5 times 24, that is 120. Divide the 3 out, and I get x equals 40. All done. All right, so that's our intro to similarity theorems. We had angle, angle, we had side, angle, side, and side, side, side. Guys, just to sum it up, the biggest thing, the mistake that new students make when they're learning this is they forget that they need to write out the fractions every time they write the letter S. So if you write down a letter S as your theorem, you need to write down a fraction that goes with that. Okay, that's all for now. Hope you enjoyed, and we'll see you next time. Bye.